Hello everyone. Today I'm going to walk through the basic installation for an SP1250LX. On the table here we have basically what comes in the box. You got the main UPS. You got the battery cable. You've got the cable for the dry contact closures on the front panel. A communication cable. The generator, we call it dongle for a bypass box if it does have a generator input, and the bypass box itself. A couple things about the bypass box. There are 4 versions of this, and it's an SPD 302, and that's the basic version. And there's also an A and a B and a C, and the A has the generator input, which is behind the cover plate here, and the B has the GFI receptacle, and the C has both of them, and that's the differences between the 4 different models of that. So we have a cabinet over here, and we have most of the stuff installed already. In this particular cabinet, obviously the bypass box mounts up here. The bypass box, unlike the older SP1000, you need to break hot and neutral. So normally your utility that comes in out of the ground or wherever, the first place it's going to go is to the bypass box here. Hot and neutral utility in, and then the output to the cabinet is going to go to where you would normally feed utility on the cabinet. So once you get that in, and we've just got this, going to a cheater cord and plugged into the wall. The cable for the UPS, is pre-installed. So it's pretty, simple at that point. In fact, before I do that, let me talk about the batteries for a second. The batteries, the cable on the battery is designed to extend out longer on one end of the battery. So if you just make note of that and you put the batteries in a particular direction, so you have a little more slack on the cable and it's easier to access it when everything's on the shelf. And one thing that you want to do that we recommend is after you plug everything in is insert a tie wrap around that connector like that. And it just keeps, if you're troubleshooting or you're pulling other wires or doing anything in the cabinet and moving stuff around, it keeps one of these from getting dislodged. This happens to be a 1250, so it's a 72 volt system. All the batteries are in series. If any one of these gets disconnected, the whole battery string is open. And if you don't catch it, then when you have an outage, it's not going to back you up. So we recommend doing that. The next thing is, any of you that have installed one of these, you have probably noticed that this connector is tight to push in. And we'll talk more about that later. But if I would recommend getting a can of any type of a silicone spray, and don't spray it in the unit, but you can spray it on the connector, and it just makes inserting that connector easier, especially if you're doing a lot in a day. A little bit easier on the hand. Plug the battery connector in. You'll notice we get a lot of calls, and even when we go out in the field, we see a lot of cases where this connector isn't seated all the way. And the one easy way to tell is if you look at the distance between the connector here and the battery connector. This connector, the input-output connector, is about 1/8 of an inch in further than the battery connector. If they're flush, this guy's not seated all the way. And if it's not seated all the way, it can cause a whole host of problems, depending on which one of these connections is intermittently making contact. So with both of those plugged in, and then in this particular cabinet, and I'm not sure about some other cabinets, but there's a cable here that plugs in for our fan that converts it to an IEC connector so that you can plug that into the front of the unit here. And since we're all plugged in, I don't know if you can hear that, the cabinet fan just started running because we've already got power going to the bypass box. So even though the unit's off, there's internal automatic bypass, so it's feeding utility power to the output. So then you want to make sure that the DC circuit breaker is on behind the switch guard. We run across that also where that's been overlooked. And turn the system switch on. And she boots up and shows that it's in the normal mode. Utility voltage, output voltage, status of the relay contacts, and the status of the unit in general is okay, and your battery voltage and battery percentage. Going back to the bypass box for a moment, when the bypass switch is in bypass, it removes utility power from the input of the unit, so it automatically puts the unit in backup mode running on batteries, but it also removes the load from the unit, so the unit's just sitting there idling with no load on it running on batteries. So it's normal for it to say input bad or AC line bad anytime you're in the bypass mode. And switch that back and it reapplies AC power and switches back over to a normal after about 4 or 5 seconds. Okay, so that covers the basic installation of a unit. Now I was going to talk about a couple of the common problems and how to troubleshoot them. One of the common problems is you lose power and it doesn't back you up. 90+% of the time when that's the problem, it's typically related to batteries or the battery cable issues. So normally what I suggest doing, first thing is measure the battery voltage on the string. Like I said previously, all the batteries are in series. So pulling this out and taking your meter and hitting it on the two contacts there, if you don't have on a 72 volt system, 75 to 80 volts in that range there, you have a problem. I mean, typically you're going to have that, you're going to have zero, or you might have it down by 24 volts, which would indicate a bad cable, especially if it's a new system. If you don't have anything there, what you want to be looking for is make sure all the battery cables are connected, and occasionally what we see is the metal contact inside these plastic bodies slides in from the back and it hooks over a flat piece of spring steel, and every once in a while one doesn't lock in place, and when you connect the two together, that contact recedes back in the body a little bit, and the connection can either not be there or it can be intermittent. So if you're not getting your voltage there, then you want to unplug all the batteries and inspect the cable end and inspect the battery end to make sure that those connectors, you can see it's rounded on the end, and it slides over and hooks on that little flat piece of spring steel in there. And make sure that they're hooked on, and then measure your voltage again. The other thing you can do, you can measure the batteries statically. Just measuring the voltage of the batteries will tell you, can tell you if a battery's bad, but it won't necessarily tell you if the battery's good. To tell if the battery's good, you really need to put a load on it and then see if it supports, if that voltage stays up under load or if the voltage crashes. Most of our units are designed to shut off when the batteries get to 10.5 volts. So on a 6 battery system, that would be 63 volts. So if you have one bad battery, as soon as you go on a battery run and the load is actually put on the batteries, if one of those batteries starts to die and that voltage drops below 63 volts, the unit's going to shut off. So if you can't find anything bad with the connectors or whatever, the next step is to look at the batteries. And if you don't have a load tester available, In a pinch, you can swap out known good batteries from another intersection, temporarily just to try it. Or if you really think it's the unit, you can it's a little bit easier to swap the unit out. You can take the unit over to another intersection where it's working fine and swap the unit out and see if it's working. The next somewhat common problem is overload. And a lot of times when you see overload, you're going to see general failure on the screen. Probably over half of the general failures that we get are related to being overloaded. And the way you want to, what can cause the overload is obviously, too much load on the intersection. If you've still got some incandescence, we've had situations where it was all LED and they had a knockdown and somebody brought a whole pole assembly out and they didn't check. And it actually had some incandescence in it. I don't know if we're going to find that anymore or not. But so to help figure out what's causing an overload issue, it helps if you have a current clamp. So you can isolate where in the intersection the overload is coming from. If you're not sure it's an overload and you think it might be a problem with the unit, one thing you can do to help isolate the unit is if you switch, again, if you put this in bypass and if the unit's already overloaded, it's going to be off because it would have shut the inverter off. So in bypass, cycle the system switch, put it back on, and cold start the unit. And if the unit boots up okay, there's a good chance your problem is an overload, because in the bypass mode, there's no load on the unit and it has no AC. You're just running off the batteries. So as far as an overload, you also want to be mindful of if it's on a particular phase, you might have to wait for that phase to come around. So if it overloads or general fails immediately when you turn it back on, or if it maybe does it after a minute or 2 minutes, it might be a particular phase. When it gets to that phase, that it's doing it. And at that point, it's real helpful to have a current clamp so you can measure the current. Again, in a pinch, if you don't have a current clamp or anything like that, you can take the unit to another intersection. And if you do that, I always recommend swapping both. Take this unit to a working intersection, see if it works, and also take the working unit, put it in here, and see if it fails, to help determine if it's a cabinet intersection issue or if it's a UPS issue. And I think after this video, I think there's going to be a question and answer segment. So hopefully you guys will have some questions that we can answer. Thanks for watching.